All right. Hit done. Check my room one more time. Room looks good. Let me share my screen. Start the broadcast. Optimize for video. And let's go here. 2 p.m. View. This is a single page. Okay. All right. So, greetings, scholars. Let me see. Hope everyone had a good weekend. You know, last week was a short week for us. I think we met one day last week. So our midterm was due, I think, Sunday night at midnight. Right. On any of your assignments, if you made below a 90, may I encourage you to you can always go back to improve your score. If you are going back to do old assignments to improve your score, I would encourage you to prioritize your exams as they have the heaviest weight. So that's the heaviest weight. Those assignments are where you're going to get the most bang for your buck. If you're going back to do the homework is going to be a lot of work for little points. The homework and quizzes are really there to kind of get you ready for the exams. It's like practice and we give you credit for it. It's not a temp grade. It's an actual grade. But again, the homework grade is like a lot of work for little points. Most of your points come from the exams. Okay. As usual, if you have questions about anything, feel free to unmute yourself to get my attention or type in the chat. So we're just going to continue working on chapter 1. All right. So this is week 5. So week 4 was exam 1. So then at week 5, if we're continuing, that means we're working in section 1.4. All right. So with section 1.4, library of functions, what this is this is the introduction, or we're starting to explore how do we graph these solutions, right? So I think you've seen where, we might either go to our graphing calculator, type y equals and then type it in. We might use something like either GeoGebra or Desmos to get a digital graph. The first official way that we have for graphing equations involve basically plotting points. So choosing several x values, passing them through the function, generating a set of output values, and then plotting the ordered pairs and connecting the points with either a straight edge or a smooth curve, right? So now we're going to get into some slightly more sophisticated ways to graph some of these functions. And so again, we introduce this by exploring a library of functions. So this section is rather long. We're going to do the best we can today to get through as many of these slides together. And then on Wednesday, we have one of two options. Either we can continue just kind of going through this lecture, which you already have access to. All right, so anything that I would say in this presentation is already in my recordings. Or on Wednesday, we can go through as much of the homework together pertaining to this section as we can, right? I personally would rather go through the homework because you already have access to the pre-recorded lectures, which is basically going to be the same thing I would say live, right? So, but for today, let's take some time and get through as much of this together. And so with this section, a few objectives. 1, we'd like to define what do we mean by a linear function. 2, discuss important properties of functions. 3, we like to graph square root and cube root functions. 4, we like to evaluate and graph piecewise functions. 5, we like to graph basic functions. And 6, we like to find the average rate of change of a function. Okay. So then we introduce a library of functions with linear functions. So let m and b be real numbers. Okay. Slightly different setup here. You guys can't see this. M and b be real numbers. The function f of x equals mx plus b is called a linear function. So you may have seen that before as y equals mx plus b, right? It's the same thing. If our m is 0, the function f of x equals b is called a constant function. If m is 1 and b is 0, the resulting function f of x equals x is called identity. So this actually, these are our first 2 functions from the library of functions, and these are both linear functions. When you have y equals some number, that's a horizontal line through y equals whatever that number is, right? So when your slope is 0, we just have a horizontal line. That's called the constant function. So that's our first function that we introduce. The second one that we typically talk about is called the identity function, where we have y equals x. So for our discussion, f of x is interchangeable with y. It just means the same thing. Sometimes we use function notation f of x. Sometimes I'll refer to it as y, but we can use f of x and y interchangeably. Okay. So then the graph of a linear function is a non-vertical line with slope m and y-intercept b. Notice that with this first graph, let's go to this color. With this first graph, as we trace it left to right, notice the image goes up. As we trace this graph left to right, it goes up, right? So that line we say has a positive slope because when we trace it left to right, it goes up. The graph on the right has a negative slope because when we trace it left to right, the graph falls. It goes down, okay? So, and again, so whenever we're talking about the slope of a line as far as positive and negative, it's always based on tracing it from the left to the right. So as we trace it left to right. What you see on the left-hand image here is the graph, the general graph of a constant function. For instance, like if that were y equals 3, then it would be a horizontal line through y equals 3. If that was y equals 1, horizontal line through y equals 1. If that were y equals negative 7, that horizontal line is going to be below the x-axis, but it's going to be y equals negative 7. If that were y equals 1,233, then there would be a horizontal line through y equals 1,233. So notice with that first image, the slope is 0, y through that number. So then the second basic function that we talk about is this diagonal, the identity function, y equals x. So it's a diagonal line through the origin, okay? Slope of 1, y-intercept is 0. So here we're asked to write a linear function where g of 1 is 4 and g of negative 3 is negative 2. Okay. So the first thing I'd like to bring to your attention, they gave us two different ordered pairs. They're basically saying when x is 1, the corresponding y is 4. When x is negative 3, the corresponding y is negative 2. So let's make a note of that. When x is 1, let me put this set to 3. So when x is 1, the corresponding y is 4. When x is negative 3, the corresponding y is negative 2. So then I'm a fan of whenever we have ordered pairs like this, just go ahead and automatically label it. x1, y1, x2, y2, okay? Then if we want a linear function, we want to fit it to the y equals mx plus b. We just saw it a moment ago introduced as f of x equals mx plus b, right? I think before we made a statement, whenever we're working with lines, it's ideal to have 3 different equations ready to go, right? So we have our slope intercept, which you already see on the screen. This is our y equals mx plus b. Another formula to have ready to go is the slope formula. And so the slope is going to be what? The rise over the run, which is the change in y over change in x. So that's going to be y2 minus y1 over x2 minus x1. Let me clean this up. Okay. Equals. Okay. So essentially, we'd like to find the equation of the line passing through these 2 points. So first, let's go ahead and use our slope formula to find the slope. And then, we'll use that to find the equation of the line. Okay. So then our slope is going to be our y2 minus our y1 divided by our x2 minus our x1. All right, so notice I replaced each component with a blank set of parentheses. I'll check my attendance again in just about 2 minutes for anybody that's like running late so they can get in. And so then with the blank parentheses, this helps us to keep track of our signs. So then we do our substitutions. Our y2 is going to be negative 2. Our y1 is going to be 4. Our x2 is going to be negative 3. Our x1 is going to be 1. Yeah. Okay. So then some algebra. Negative 2 minus 4 is what? Negative 6 divided by negative 4 Double negative is positive. This reduces down to 3/2. That's not a 2. 3/2. Okay. So that's the slope. So then, let me see. I kind of want to move this over just a little bit. Matter of fact, let me shrink this down. That's really just more of a reference. We'll continue working here. Okay, so we found the slope. So now, since now we could use the point slope formula, I'm just going to provide you with that formula, but I'm not actually going to use it. So point slope, we typically use point slope whenever we're given a point and a slope. And that goes y minus y1 equals m times x minus x1. But I'm not a fan of using it. I would rather use the slope-intercept formula. So we have the slope and we have one of the points. The only thing we don't have is our y-intercept. So let's solve for the y-intercept. Okay. So then my slope is 3/2. I'm going to choose the first point just because it looks like it's easier to work with because we don't have negatives, right? It's all positive. So my x there is a 1. We don't know our y-intercept. So the b, I'm just going to leave that b because that's what we're trying to solve for. And then my y, my corresponding y, when x is 1, the y was 4. We have one equation, one unknown, we can solve. And just so you, basically, that came from here. I plugged in for my slope, my x, and my y. Only thing we didn't have was b. Okay. So then if we do a quick algebra, a quick calculation, e is going to be equal to 4 minus 3/2. So what is that? 5/2. 5/2. Okay. So we got the y-intercept, we got our slope. So then if we put this information together, our function is going to be 3/2 x plus 5/2. Okay. And so then from here, it's a good, oh, and actually that should be g, not f. That should be g of x. So from here, it's a good idea to confirm that the original points work, right? So for instance, when x is 1, 3/2 plus 5/2 is 8/2, which is 4, right? So this one checks out. Okay. When x is -3, we get a -9/2 plus 5/2 is a -4/2, which is ultimately -2. So that one checks out as well. Okay, paste. Let me check on you guys in Zoom. Yeah, I like my little alteration. So it's like my my iPad case, you can like do varying levels, but when I do it on a level that's like almost flat, but not all the way flat, it gets, if I put pressure on it, it falls. So instead of using that setting, I just propped a little cushion under it, and that gives it the right angle, and it's way more sturdy. Let's see. So if we hop over here, I just want to see if we got any latecomers. Let me get the students. I'm glad he waited. Here we go. Let him in. And then let me check the chat. Okay, so with Pearson, at this point, you probably just have to purchase whatever price they're asking for. Like if your second trial has ended and the thing still has yet to be resolved, I would just, you should be prompted for payment and just go ahead and purchase the full access. And so, because if you're at that point, let me check the chat again. Yeah, we can talk after. Just remind me. We're not gonna have a lot of time, but yeah, that's fine. Okay, let's hop back over here. So we got 3/2 x plus 5/2. So, and then here's a type version of what we just experienced. So they found the slope first. I think we got the same thing. And then they use the point slope form, so you can see their use of the point slope. And then We got the same result. I guess I could do this for them as well. This is a lot easier. Okay, so next we have this topic on increasing, decreasing, and constant functions.
Sir, can you go back to the last slide real quick so I can add to my notes?
So okay, feel free. You can always screenshot this as I go. Also, at the end of class, you get a copy of this, right? So yeah, you can like just take a quick screenshot. But there's no need to fret because all of this stuff that you see, I make a copy available. To access it, you just go to our Blackboard page. Then you'll see a link that says the daily lecture notes updated. You click on that, it'll open up Box, and then you have a copy of all of this stuff since the beginning. Right? Every time we meet, I update it. Every time I do this, I update it. So yeah, you get a copy. Okay, let's keep going. Okay, so it's weird because like I'm trying to like not say and like stuff because this is a recording and I'm streaming, and it's like I keep thinking about it, and then in me thinking about it, I'm saying to myself. I was like, stop saying It's really, that's the weird part. So anyway, I mean, it doesn't really matter, but it is kind of what I think that it is that I need to do. I really just have to slow down, right? Because I want to like speak fast and like just get through it. And I was like, no, just slow it down. You know, you don't have to rush because they already have a copy. So you don't have to worry about that. There's already a recording of this, the same stuff I would say. So just take your time, right? I have to like consciously remind myself to slow down. Okay. So let's explore what do we mean by increasing, decreasing, and constant functions. So let f be a function and let x1 and x2 be any two numbers in an open interval AB contained in the domain of f. The symbols A and B may represent real numbers, negative infinity or positive infinity. Then we have the following to be the case. Okay. So first we have that f is an increasing function on an open interval AB if whenever x1 is strictly less than x2, that implies f of x1 is strictly less than x2. In layman terms, typically whenever we're working with increasing, decreasing, and constant functions, we're looking at an image. And that just means that, okay, as we trace the graph from the left to the right, the graph is increasing, is going up. So this explanation on the left is like a formal definition of what do we mean by an increasing function. But the simple thing is, it just means that as we trace the graph from the left to the right, it's increasing on that open interval. Okay. And so decreasing is something similar. The only thing that's changed, instead of f of x1 being less than f of x2, now f of x1 is greater than f of x2. So we say that f is a decreasing function on an open interval AB if whenever x1 is less than x2, x1 is less than x2, that implies the corresponding y, f of x1, is greater than f of x2. In other words, when we look at the image, as we trace the graph from the left to the right, it'll fall. Okay. So we've talked about increasing functions, decreasing functions, and then next is our constant function. So a constant function, f is a constant on an open interval AB if whenever x1 is less than x2, this implies f of x1 is equal to f of x2. All right. So notice this image is flat. It's a flat horizontal line on an open interval. Okay. I don't know, for some reason I just got this image in my mind, like, how was like campus life for you all? Like, cause I don't know, I just got this image, like, I remember just being a student and, you know, you still had to like study and devise a plan to get through your assignments. But you know, I mean, it was a campus life. Like, it was like, I know homecoming is coming up. That's usually like around Halloween. We used to do like haunted houses, the football games. I don't know if y'all were having games or not. Like, those were fun because then another thing is like, supposedly all this COVID stuff is supposed to be ramping up. Like, this is supposed to be ramping up the mask mandates and all that. I know Morris Brown had reinstated their mask mandates, but it's like, but again, I'm grateful that I'm remote. So, you know, I can kind of live my life and keep it moving. And then when I do want to engage people, then I'll make an excuse to be around people. But when I don't, you know, I appreciate being remote. I'm not gonna lie. right? I love you guys, but you know, I'm sorry, but not sorry, right? So I don't know. I just got that flash across my mind because like I'm not sure if you guys are on campus or not. I know I have some students that are like all over the world. They are not necessarily at Morehouse, so I don't know. It's different. But anyway, that's neither here nor there. Just random stuff. And I really appreciate how the time of this class too. We only got 25 minutes left. We're already at the halfway mark. Party's almost over. What a bummer, right? But let's keep it going, right? So this is a constant function. Okay. All right. So in this example, right, tracking the behavior of a function from the graph of G, find the intervals over which G is increasing, decreasing, or constant. So this is we're gonna base our results on the x-axis, right? That's the domain. Okay. So let me do my little setup here. Boom, boom. Nice. Okay. All right. So as we trace the graph going from the left to the right, notice that it's increasing, right? Let's divvy it up like in the following manner. So let's go like this. Okay. Let's take that. Let's go style. I want it to be dashed, and we can make it thicker. All right, that looks good. It's decent, I guess. Why does it look? Yeah, okay. Let's copy and paste right here. All right. So basically, I marked off where the graph changes from like increasing, decreasing, or constant. Whenever it changed, I just kind of sectioned it off. And so what this does, this breaks the image up into three regions. You know, we have like this region A, we have this region B, and this region C. Region A is everything left all the way to negative infinity of that dash line. Region B is the middle region between the two dash lines, and then region C is everything to the right all the way to positive infinity. Right? Like the way we kind of like explore infinity is like as humans, our ability to conceptualize infinity. Obviously, we're not gonna, you know, sit here and look at like get a mental image of when x is 5 or when x is 6 or when x is 7, and we're not going to do that forever. We're just going to assume that the pattern, well, not really assume, but it's like, you know, be cognizant that the pattern continues in that fashion forever in either direction. Right. So once we get a sense of the pattern, then knowing that the pattern continues forever, we can jump to any like outcome, like when x is 10 million, what's the corresponding y, right? We can jump there, but we're not, in our minds, we don't have all that stuff, you know, all at once like that. There's that again. Okay, so now when we're talking about increasing, so as we trace the graph from the left to the right, initially the graph is increasing. So I'm gonna abbreviate that by just doing an up arrow. We're gonna say the graph is increasing on the interval as x goes from negative infinity up to, what's that x value? -2. So whenever we do increasing, decreasing, or constant, we typically use parentheses. There's a little bit more to that story, but that's the gist of it there. So then in region B, we see that as we trace the graph from the left to the right, it's flat or horizontal. So then we say that it's constant. I'm going to abbreviate constant as a horizontal line. Okay, that means it's constant on the interval as x goes from where? -2 up to 3. Again, these intervals are based on the x-axis. Let me just move this stuff around just a little bit. Just kind of align them a bit. Okay, that looks decent. And then for the third region, we say the function is what? Decreasing as x goes from 3 to infinity. And like, I'm not gonna lie, I'm really grateful for like the technology, like working on the tablet. Like in the olden days, like in the before time, I would have to be in person at a board, either using chalk, which is like messy and dirty, and it feels really weird, and it kind of makes my skin crawl. But I would use it. I didn't mind using it, but it's like I had to like focus to not have that effect on me. Or I would be using markers where they're constantly running out. I have all this material. I didn't, you know, I was totally uncomfortable. It's hot, you know, it's just like all this random stuff. I mean, we had some experiences, we had some fun, but I'm not gonna lie. I really enjoy like working on my tablet. Like as long as I have some power and the internet, you know, we can engage and do what we need to do. And it's really exciting to me because we're just talking about math, but we can do anything. We could talk about music, gaming. We can either play games or create games, writing, and then you couple this with Chat GPT. Like Chat GPT is so much fun. Like if you ever want to do any kind of creative writing, but you're not a writer like me, then you can just load the prompts into Chat GPT. You could be like, hey, write me a story about a dragon, who slays whatever, and you can tell it all the things that you wanted to be in there. And and then when you get the story, you can tell it to edit it. And it does it in like a second. It's so much fun. I had a student last year. I swear you guys are geniuses. And honestly, this school is just these institutions are really just getting in your ways for many of you guys. Like this student, he I don't know if you ever play for instance, I play Mobile Legends. You can see some of my gameplay on my YouTube channel. But in the gameplay, it's basically like a 5-on-5 battle royale. And each character has different traits and abilities. It's like a live modern mobile. It's a modern version of chess. And so you have to you have 6 different roles that you have to try to fit into 5 slots. So what that means is that at least one player, if you want to cover all the different roles, one player has to play a switch. They need to play more than one role, which is oftentimes me. But I have to trick it gets into psychology so much. One of the matches I played last night, I had to trick my teammates. I pretended like I was going to be the assassin. So then my other teammate at the last second chose tank, and then I switched into multi-role. So then by the end of it, it was all field. But if I had showed my true character from the get-go, they would have thought I was trying to troll. I was like, no, I'm not trolling. I'm actually really good with this player, but I need you guys to fill these roles. So I had to trick them. So I got them to play tank, then I switched over to Diggy, and then we dominated the opponents, man. It was brutal. I was like, oh man, I felt so bad for them because it was a thing of beauty. I have a copy of it. I don't think I'm gonna load it. I should load it, and I probably should try to pull the copy. Hopefully, it's not too late. But I bring it up this game because this student. So where you have all these different characters that have all these different abilities and roles and traits and things, that's all that he would do. He would just create characters that have different abilities like that. Where I'm playing this game where I know they're making millions of dollars, he's creating it. I'm like, yo, that's I'm still, every time I think about it, I hope that he's still doing that. And especially with something like Chat GPT, he just needs to collab with people animators. My nephew just started animation school. I'm more the type to encourage people. If you're passionate about something, if you have fun doing something, you love it, find a way. You want to get to a proficiency level where everybody acknowledges your skill level and they pay you for your expertise. And it could be anything. There's nothing that says you have to be this or that. As long as you're passionate about it and you're good and people start to acknowledge you, if you can get paid to do it, to do what you love to do, you never work a day in your life. So that's kind of not that I got anything figured out, but I'm on that track, on that path or whatever. So if you couple that student's ability to create those characters with something like Chat GPT and Mid-Journey and the animation studios and all that, I even saw something. This will be the last story, and we'll get back on track. I saw something recently where this company made a live dynamic South Park creator, South Park episode creator. They basically use Chat GPT and some other AI, where it's you have these little South Park bots kind of roaming around, and then you can create different scenarios. When they bump into each other, it'll automatically create 30-minute episodes based on whatever little parameters you give it. We are definitely on the edge of the future. We just got to survive all this chaos that's coming down the pipeline. But we are definitely on the edge of the future, just like in Black Mirror. And Black Mirror is kind of weird and trippy. It's the concepts and the technology is exciting, but those are very plausible scenarios that can happen. And it's kind of trippy. Like you might want to, if you do watch that, try to get past that first episode. That was a little bit weird and bizarre, but the other ones are trippy, but they're reasonable. It's like, dang, you can see how we could experience that in our lifetime. Especially if you think about like Elon Musk with the not Neuralink, but that brain thing where he's wiring people's brains, he's putting chips in people's brains. And like honestly, I think it could have saved like one of my loved ones' lives. Like, because they had a surgery and then the doctors were like, well, we could have saved them, but then they would have been paralyzed. But then now with this like brain thing, the way that works is they put a chip in your brain. It's like basically they're turning their brain into like a Bluetooth transmitter. So like if somebody's paralyzed, they put a receiver past the break point and they can link their brain to whatever the paralyzed region is, and they can restore functionality. So like we're becoming cyborgs, but then when you take it to the nth degree, then you start getting things like Altered Carbon series or Black Mirror and stuff like that. So anyway, we got a solid 10 minutes. Let's go ahead and take 10 minutes to keep going here. It's just really interesting stuff. I kind of talk about it because it's recording and at least it's on file somewhere. So at some point somebody will hear it because it's really interesting stuff, but it's like Easter eggs kind of, spread around or whatever. Okay, so getting back on task, we have the definition of relative maxima and relative minimum. If A is in the domain of a function f, we say that the value, oh shoot, I just realized I need to make videos of them too. I can't do that stuff in advance. I don't be thinking about this stuff until it's time. Okay, so if A is in the domain of a function f. Morehouse? Okay, let me see. This is why it's important to be on time. He's lucky I stopped and looked at that. Let's see. Let me get these gentlemen. Let's see. His last name isn't showing. I see him. I think it's him. No, maybe it's this one. See. Let me see how he spells it. I think that's him. I think I got him. All right. All right, gentlemen, welcome. Yeah, so you got lucky because one of you guys sent me an email and it caught my attention. I checked it. I saw it. You're lucky if I see those emails in class, right? And so, I went on and gave you attendance credit. I usually check attendance twice, like once right at the start of class and then once at the 15-minute mark. And then again, the only reason I checked it because I saw your email, so you got lucky. But I went on and gave you guys credit, but you got to be careful getting into those after that 15-minute mark. You're kind of at my mercy. Okay, so I'll let you kind of read through this on your own, just in the interest of time. When we're talking about relative maxima and relative minima, essentially what that is the bottom of valleys and the peaks of mountains, right? So we say that f of A is a relative minimum if the simple thing is it's immature, right? So, for instance, we're saying that this is what we mean by relative minimum. It's the bottom of a valley, right? And then this is a relative max, the peak of a mountain or a hill. So if you ever see relative max or relative min, we're either talking about the max is going to be the peaks of the mountains. The relative min are going to be the bottom of the valleys. And not to be confused with absolute max and absolute min. Relative max are just these images. Okay. So a function is called an even function if for each x in the domain of f, negative x is also in the domain of f, right? The definition of even function, whenever we evaluate f of negative x, we get back to the original. The graph of an even function is symmetric with respect to the y-axis. Okay. So again, the definition of an even function, f of negative x equals f of x. The definition of an odd function, f of negative x equals negative f of x. All right. So again, even f of negative x equals the original. Odd, f of negative x equals a negative times the original. A negative times the original. Okay. Odd functions are symmetric with respect to the origin. Let's try to get to the next example. That'll probably be the last one for the day. And this will kind of showcase even, odd, and either. So here we're asked to determine whether each function is even, odd, or neither. Okay. So to do a test for even, odd, or neither, we replace x with negative x, we simplify, and then we interpret the results. So then for A, first we're replacing each x with negative x. Replacing each x with negative x. Okay. So then we simplify. So when we have an odd number of negatives multiplied, the final result there is going to be a negative. Double negative is positive. Is this the original? No. So then let's try factoring out a negative. If we factor out a negative from all terms, we're going to be left with x cubed minus 4x. And then notice that this is a negative times the original, right? So then we have g of negative x equals negative times g of x. That's the definition of a function being odd, which means we have x-axis, origin symmetry. We have origin symmetry. Okay. Style. That is good. Mm-hmm. Let me just shrink this down a bit to kind of get it. I see the time. I'm about to get you all out of here. Down just a little bit more. Okay. So then let's work on B. Again, we're replacing each x with negative x. So we have f of x equals x squared plus 5. And again, we're replacing each x with negative x. And then we simplify. So double negative is positive. So since we have an even number of negatives, that's going to be a positive x squared. Is this the original? Yeah, right? So then notice that f of negative x equals f of x. That's the definition of a function being even. Okay. And let me just shrink this down a bit just to create some space. And then like being able to edit the stuff like this, like it's like fun. And it just, it's a nice, I like the presentation, anywho. And then lastly, let's do the same thing here. So for C, replacing each x with the negative x. I'll run out of space a bit. Negative x, and negative x. Okay. I'll work here. So odd number of negatives, that's going to be a negative 2x cubed. Then that's going to be plus x squared. Is that the original? No. If we factor out a negative, can we get back to the original? No. So that's an example of something that's neither. It's neither even nor odd. Okay. Getting you guys out of here. I see the time. Actually, we still got like a full 3 minutes. Okay. But that's enough. Okay. All right. All right. Are there any questions? Once. Going twice. Okay. So let me go ahead and make a copy of this available for you all. Let me share, send it to Box. Let me make sure it's in the right folder. So this is 23, traditional, College Algebra 1, the notes updated daily. Yes, this looks right. All right, we're gonna send it here. All right, so when this bar finishes loading, you'll receive a copy of everything that you saw me writing. So as you review your notes, you can always pull it. We made it, just shy of halfway. So then when we meet again on Wednesday, we'll have an option. So, just kind of be ready. On Wednesday, we can either continue with the lecture like this, which again is already in my recordings that you can watch right now, or we can go through the homework, which is my vote. I'm thinking more than likely I will go through as many homework questions together on Wednesday. So we're going to do a homework session. Okay. If there aren't any burning questions, we'll end the session here. And from one beautiful mind to another, enjoy the rest of your day. See you all Wednesday, same time, same place. Take care. Peace. I know there was a student that was requesting to speak to me. I don't know if you're still there or if you still have the question or concern or anything.
Yeah, I'm still here.
Did it get resolved or?
Yeah, I just wanted to ask if I could come to your office hours to possibly get help with some questions I have definitely about the exam we just had, and then just all the other problems that I was having trouble with.
Okay, so I'm glad you're mentioning this. Let me hopefully I can catch people before they leave. Let me say this real quick. I'm just pulling up an email I got this morning. Let me find it. Here it is. Okay, so this morning I got this email. It says, good morning, starting Monday, September 11th, which is today, the mathematics tutoring will be available in Dansby Hall 304 on Monday and Wednesdays from 3 to 5. There will be at least 3 tutors, and the courses to be tutored include College Algebra 1, basically our course, and some others. Some tutors may be willing to tutor upper-level mathematics courses. If any questions regarding this, please contact me. I got this from Alicia Austin. So, yeah, so the tutors are good. Yeah, you can definitely attend my office hours. My office hours are, that was today. That was my bad. I totally blanked out today. I had to get some rest. But yeah, office hours are Monday and Wednesdays from 10 a.m. to noon. Another option is, so as you're going through the homework, click on the Ask My Instructor and it'll send me a screenshot of your question, and I'll try to load it or respond to it as soon as I can. With the exam, if you want to challenge some questions, screenshot those as well. The homework you can use to Ask My Instructor, but with the exam, screenshot it and email it to me, and then I can look at it, when I get a chance, and we can do that as well.
And you said the tutors are also in dance from 3 to 5 on what days?
Monday and Wednesdays from 3 to 5, and Dansby 304. So it's the 3rd floor Dansby. It's like a math lab. It's a big lab.
Okay.
Yeah.
I can utilize those as well.
Pardon?
So I can utilize those as well.
Yeah, tutoring, office hours, your classmates. Now, for me, if you're for instance, with the exam, if you want to challenge some of your results, you would have to come to me, because then, I can look at it and be like, oh yeah, that's right. And I can give you points retroactively. But if you just need help, questions, homework and stuff like that, you can still ask me, or you can ask the tutors. I do encourage you all to work together. So I don't know if any of your classmates are getting it, but anybody that seems like they're getting stuff correct, it doesn't have to be just me.
Okay. Thank you.
Any other questions, comments, and concerns before we go our separate ways?
I have a question.
Yes.
So about Pearson, right? Because my free trial is about to end. Did you ever discuss with them how to lower the price or something? I remember you were saying that.
I don't know that that's ever been resolved, because I haven't seen any kind of correspondence. Let me send a text to my supervisor. Let me see if he says anything. Give me just a moment. No.
All right.
So, greetings. Greetings. Has there been any update on the reduced price for Pearson? Okay. So I just messaged my supervisor, and then I'll forward whatever, actually, yeah, let me see if I can. Let me actually try calling him. Give me just a moment. He might be getting out of class. Give me just a moment. Get down. Get down. Thank you. Get down.
Hey, Charles.
Greetings, Dr. Clark. How's it going? I had a quick question for you. Has there been any update on the pricing for my math lab? Right, the fourth week, yeah. College Algebra 1. I see. Oh, okay, that's what's going on. Yeah, that makes sense. Can I call you back in like a few minutes? I actually have my students here. Yeah. I'll call you back in like a few minutes. All right. Yeah. So okay. So it still hasn't been resolved. So your best bet is probably just to go ahead and just try to purchase it. It was supposed to be resolved before the semester started, but I think I know one administrator retired. So then when you have a change in administration like that, it just mucks stuff up. So it seems like it's not resolved. So the best thing is probably just to go ahead and purchase the full thing.
Yeah, all right. I had actually like the beginning of the semester, I had bought like a textbook. I think it like in the front of it, it like
Right.
has like a little My Math Lab kit thing. Is that the My Math Lab? Like,
Yes.
can I like, so if I bought that already, I technically already have it.
Yeah.
I just
So like on that page where you're prompted for payment, it says enter an access code. That My Math Lab thing, that's your access code.
Oh, okay, yeah, because like I haven't, it's still in the plastic, so I haven't even opened the book yet. So
Yeah, you would
I have to.
use that, and that'll give, and you can just keep working.
Oh, okay, all right, appreciate it. Have
Okay.
a good day.
Well, all right, gentlemen. Any other burning questions? Going once, going twice. Okay. All right, gentlemen. So we have our assignments, and again, we'll meet on Wednesday, same time, same place. Good luck with everything, and from one beautiful mind to another, guys. Take care. Peace.